we have Dr. Livingston Martin, who is joins us from the Family Medicine Department. He is actually a clinical informatics fellow, and I'm glad we were able to get you scheduled with us, Livingston. Thank you so much. He's going to be giving us a talk today about artificial intelligence in nephrology. So certainly a timely topic for all of us. So Livingston, if you want to try to share your screen.
Yeah, of course. Let's see.
That's
All
perfect.
right, can you see my screen?
Yes, looks great.
All right, so yeah, thank you. And so I'm a practicing family medicine physician, and a lot of folks are asked, like, what is clinical informatics? And I had that question at one point as well. It's a 2-year ACG-Me accredited fellowship at the University of Washington. We do a lot of stuff with electronic medical record improvement, data, big data, AI. Yeah, and so I'm just gonna give you a quick overview of AI in nephrology, but disclaimer, I am not a nephrologist, so family medicine. So here's our learning objectives. Disclosure, I used to have a AI LM startup. No business was conducted, and it dissolved last year in May 21st. So here's an overview of our talk. I essentially decided to split it into 3 main components. So number 1, we're going to talk about what is AI and sort of demystify a little bit of this language, because it's sort of thrown around a lot, and trying to separate it a little bit. And then I'm going to describe some ways it may affect your practice. And I tried to put a little nephrology spin on it as well to highlight some things that are more relevant. And then I'm going to discuss some ethical concerns and challenges. And I'll try and leave some time at the end so we can talk about stuff just in a conversational way. So first, what is AI and large language models? So before we get into it, I want to describe this Gardner hype cycle, which you may or may not be familiar with. Whenever there's any sort of disruptive innovation, it tends to go through these phases pretty consistently. So we discover something that's an innovation, and then people are really excited about it and have some inflated expectations. And then it inevitably fails to meet your expectations in the short term, but long term, it has pretty significant effects on our life. And an example of this would be the internet. The internet was a disruptive innovation. We had the dot-com bubble, and then can you imagine your life without the internet? I mean, we wouldn't be talking on Zoom. AI is up here right now, so I think the message is prepare to be disappointed, but don't underestimate where some of this technology is going. So first, it's useful to sort of think about how we traditionally interact with computers. And so you have an individual called a programmer, and a programmer writes code or very specific instructions for how a computer should behave by a defined set of rules, and that results in a program. So you have the computer executes that code in a very predictable way. And so one way of looking at that is there's a known set of rules that are applied by the computer on input to generate an output. And that's how all current programming works. And here's our roadmap for how I want to sort of go through this. So we're going to start up here at artificial intelligence. And this is a description of how these things are related. So for example, all of machine learning is contained within artificial intelligence, but it's sort of a bigger Venn diagram. And then we're going to keep going all the way down to the middle and describe each of these circles. So keep in mind that each category is contained within the larger category. So first, artificial intelligence. Intelligence is just the ability to learn and perform suitable techniques to solve problems, achieve goals, and adjust to an uncertain and ever-varying world. And so by that logic, artificial intelligence is the science and engineering of making intelligent machines. Cool. All right, let's talk about machine learning. So machine learning is the part of artificial intelligence that studies how computer agents improve their perception, knowledge, thinking, or actions based on experience or data. And there's 3 main categories of machine learning that we'll talk about: supervised, unsupervised, and reinforcement learning. And here's a comic from a comic strip I like called XKCD that, is this your machine learning system? Yes, you just pour your data into a big pile of linear algebra and then collect your answers on the other side. And what if the answers are wrong? Well, you just keep stirring the pile until they start looking right. And many machine learning algorithms sort of fall into this pattern. Supervised learning, this is essentially where you train a model based on human labeled data. So a human has gone and looked at an image, for example, this image, and said, this is pneumonia. And so I want you to label this as pneumonia, label this as not pneumonia, and then you use that to train a model and then ask the machine learning algorithm to identify next pictures that fit the previous pattern. And it compares that with its training data to determine whether this is pneumonia or not. And so you have an individual who specifically gave that label to this picture. One issue with supervised machine learning is it takes a lot of time. You have to ask a person to spend time out of their day to individually label things. But yeah. Unsupervised learning is another form of machine learning, and that's where you train with no explicit labels. So this is where an algorithm is identifying patterns, groupings, structures that are present within the data, and using that to separate things into groups. And so you would give this kind of picture to a unsupervised learning model, and it would be able to separate this with, this is clumped and grouped with other things that are white and fluffy with this sort of change in opacity in this corner, but I don't know what it is. I just know it's separate and different from something else. And so this would be analogous to a computer looking at something that is pairing like with like and grouping by categories. But it doesn't require someone to tell it what to do. And it just knows it's white and fluffy. It doesn't know that it's pneumonia. And then reinforcement learning, this is essentially playing a game. So it's a machine learning algorithm is interacting with its environment, and it's taking different actions in order to optimize its total rewards. And so it gets it makes a change or tries something, and it gets either a feedback, penalty, or reward depending on how that change worked out. And so this would be an example of using an algorithm to improve the accuracy of pneumonia detection. So it would slowly tweak and change settings over time, and get feedback on those changes to see if it was making an improvement or not. And so this is like I played a game, and this is the picture that won the most points. So therefore, I'm selecting it. So machine learning has some drawbacks, and this is an example of a picture that would be incredibly confusing for a machine learning algorithm. So my question to you is, which of these is a dog and which of these is a muffin? Now, we have the advantage of seeing lots of dogs and muffins and being able to tell them apart relatively well, but a machine learning algorithm would just say, you know what, it's yellow and there's a couple black dots and I don't know, it's all the same. And so being able to separate these things would be an incredible challenge. And so machine learning is a little bit different because from traditional programming, because you're taking both the input and the output, and you're sort of generating the rules for how you're going to interpret that, and then applying those rules to data. So just comparing it with traditional programming, you're going from knowing the rules in advance to sort of generating a new set of rules based on the training data to apply to new data. And that's sort of a fundamental difference. Okay, so now we're going to move on to deep learning, which is a subset of machine learning. So deep learning introduces this concept of neural networks. And so neural networks, it's called that because it was inspired by like neurons in the human brain. There's nodes that have input layers that change something and then sends more data to output layers. And so it's sort of like this network. And it's often it's a type of model that's very helpful for very complex data patterns. And so far, it's been the most successful machine learning approach. It's very good at generalizing using a very small data set and scaling to big data. This is sort of when you have the concept of training models. So you'll train the model on a lot of information, and then you can test it on different things and then see if it's successful or not. Here's an example of what a deep learning neural network does a little bit with these neurons. So I've asked it this question: what is this object? I don't know what this object on the left is. Well, first I'm going to have this input layer of neurons. I'm going to sort of fire this neuron for blue and red and white colors, and then this sort of bulbous head picture and then this overall impression. And then there's multiple other neurons in the neural network that will fire that are weighted heavily. The concept of the word blue, the sort of teeth structure, and now we're hot firing elements related to eyes and face and animal. And then now we've got finally, after all these networks, these neurons have fired, we're getting to this output layer of linking to the word blue, the word octopus, the word cute. And now we have a final analysis of asking, what is this object? Well, it's a cute drawing of a blue octopus. And so it's going through this process of different neurons firing differently depending on how they're weighted based on the training data. So a comparison between machine learning and deep learning, the key thing is being able to tell why it made that choice. So the feature extraction is a big deal in machine learning. So if you take a machine learning algorithm and you train it, you can see what you can be told distinctly what features are being highlighted for it to make its decision. And that's nice, at least in medicine, especially because you can see like, okay, what were you looking at? What did you weight heavily? Whereas the neural network deep learning algorithms, you don't really know. So in my simplified example, there's only a couple neurons, but the reality is there's millions of neurons in this big map of neurons with all these different weights. And so if you try and ask a neural network or deep learning algorithm, how did you get to your answer? You don't know. No one knows. It is just this massive weighting of neurons over multiple different weightings depending on the training data. It's sort of like me asking you, like, why did you decide to have oatmeal for breakfast? It was a complex network of things. You remember this oatmeal you had last week. You had it in your pantry, and so there's this complicated web of things that led to that decision that can't really be deterministically identified. So when we talk about performance, so in general, so you and I, we tend to get a little worse with large amounts of data. So our performance sort of peaks at a certain level of data, and then you keep giving us more data, and humans get worse and worse and worse over time, just because there's so much to pay attention to, it's impossible. Machine learning, traditional machine learning approaches tend to have a plateau at a certain point. Whereas deep learning scales with data. So the more data you give it, often the performance can really improve over time. That's why everyone talks about the data. It's high quality data is essential in having a quality output, and lots of it. And here's another a joke. I'm so tired of learning. Everyone constantly expects me to constantly improve, but they never ask if I want to. That's true. No one asks the neural network what it wants. All right. So what is this ChatGPT thing that I keep hearing about? So now we're in this space of generative AI, and notice that generative AI and deep is a subset of deep learning, and then has this overlap with large language models. So we're actually these things are a Venn diagram. So GPT, what does it mean? So the words are generative. So it's a generative. It generates coherent and relevant text based on a prompt. So it generates something new. It is pre-trained. So it has a task of being pre-trained with the goal of identifying the next word in a sequence of words and identifying the most likely word. And then it's a transformer, which is a type of that neural network architecture that I talked about earlier. So it's using a neural network, and it's really good at processing sequential data. There's a paper that came out a couple years ago that's pretty influential called "Attention is All You Need," where it knows how to pay more attention to certain parts of words in prompts and use that to generate the more accurate output. And then there's a couple examples of generative AI tools. These are also large language models. There's lots of different vendors on here. I've only included the OpenAI ChatGPT, which their flagship models, the GPT-4o. They also have an O3 reasoning model as of June, as of now. And then Gemini has a 2.5 Pro and Flash models. That's Google's Gemini. There's also Anthropic, it's Amazon's Grok, a lot of other vendors. It's a pretty competitive space right now. All right, so let's talk about large language models. So large language models, like what we just mentioned, are using this deep learning technique transformers, and they're made possible with more compute power. So the more powerful GPUs, reduction in compute cost has made it possible for these large language models to be developed and trained. And they're using that unsupervised method with the task of purely trying to predict the next word in a sequence of words. And so they have no knowledge of truth or accuracy. They're just trying to know what is the next most likely, statistically likely word in a pattern of words with the amount of information I've been trained on. And so it's just playing a very large version of this game, trying to guess what's the next in a pattern. And these models are a big deal, in part because there's a very low technical barrier to entry. They can parse and human language, so anyone is able to interact with it very easily. It generates a very human-like response. It is very effective at classifying, scoring, annotating text, and you also can iterate on it within a conversational style to work on problems. So I like to joke that congratulations, you're all programmers. The next programming language is English. So just interacting with these models is very easy and a very low barrier to entry, and they're pretty effective in that. Now, there have been some famous missteps, and these were some that were pretty notorious circling around. Since these have no knowledge of truth, they're just playing a game of predicting the next word in a sequence of words, they will give you wrong information. And the term we use for that is hallucinations. So for example, this was a user asked one of the models how many rocks they should eat, and the AI suggested eating 1 rock per day. And then it gave a recommendation for cheese not sticking to the pizza to add a little bit of glue, because stickiness and glue are probably related in the training data. Okay, so that's our crash course on AI and large language models. Now let's talk about some ways that some of this technology may affect our practice. So this is a breakdown of different ways that AI may influence care. And the size of the circle refers to the market size. And so this diagnostic circle, is an estimated $100 billion market size. And the reason why, and then the little colors on the side describe elements of the quadruple aim that it is likely to affect. So diagnostics would affect better outcomes and lower costs. And I think this is a helpful graph, because if there's a larger market size, that is an indicator for more investment in that space, because people want to have their products be used. And so they'll look at the market size and generate more products in that space. So the types of things that we'll talk about today, just because of time, are the chart review and documentation tools, a little bit of practice management. We'll touch on diagnostics, as well as some risk prediction and intervention components. So for chart review and documentation, you're probably all familiar with this one, but ambient is the big game in town. And for those of you who are not familiar, this is essentially an AI scribe. So you'll pull up, the way it works is you pull open your phone and you open an ambient dictation app and you put it on the table and make sure the patient is okay with that. And then it will take the spoken dialogue during the clinical encounter and automatically generate into a note and document for you. And this is very different than a transcription. It does not take the words verbatim. It uses the transcript to generate documentation. So if the patient spent 20 minutes talking about their dog, that would not be included. It would only include the clinically relevant information in a succinct way. And it dramatically changes the encounter, because you don't need to look at the computer and type in order to document. You look at the patient and talk, and then at the end of the encounter, you have a note ready for you, and you just can edit it in case there are mistakes. It also can use information that's previously in the chart. So it's not necessarily restricted to just what is spoken. You can have it, for example, have the patient's past medical history as well. And this is in its infancy right now, even though it seems like it's everywhere, but it's really growing pretty fast. And future state is placing lab and medication orders. So I talk about some labs and meds I want to use, and it'll pen those, and I can look at it later and sign it. We talked about a particular ICD-10 diagnosis. It will pen the correct code for the patient. It will evaluate the billing information, the level of service that's estimated based on the content of the clinical note, and it can suggest billing codes. And then another future state would be to automatically generate patient education from the visit. So you take everything that was discussed in the visit, turn it into Spanish, and write it at a 4th grade reading level for ease of understandability. And that sort of tool is in the near future. Now, these future state things I've mentioned are not here yet, just to be clear. They're things that are in development and will likely occur in the not so distant future. There's a lot of competitors in this space right now. So this is an example of all the different companies that are duking it out for dominance in the ambient AI space. I just wanted to give you an idea of how competitive this is. And yeah, little .com bubble. All right, so practice management. This is another huge area of generative AI, and primarily anything that's a repetitive clerical task in practice management is ripe for AI. An example would be insurance claims and prior authorizations. So if you could just automatically generate a claim denial appeal letter and comb the chart for all supporting clinical documentation, put that together and send the letter off, that is a possibility in the not so distant future. In-basket management tools, patient appointment reminders, trying to do automated telephone outreach, data collection. An example would be using a generative AI agent to automatically call patients for post-surgical follow-up, and then iterate conversationally with the patient to get post-surgical follow-up information and to put that information in a note and save it to the chart, sort of doing that surgical outreach. And another example would be the augmented response technology. This is where you receive a patient message from the in-basket, and the generative AI model drafts a response to that message. And so it changes the job from writing a reply to the patient to looking at the generative reply and editing it if needed and sending it back. And what's funny is there's a paper that came out I think it was a year and a half ago now, but for augmented response technology, and they asked patients, what do you prefer? Do you prefer the physician response or the art response? And patients overwhelmingly preferred the AI art response because they felt it was more empathetic. It was longer and more patient-centered, and it had a lot of other language that patients tend to like. And then billing and coding is another major area. So evaluating documentation, suggesting the appropriate level of service for billing, automatically adding procedure codes, and then auditing your panel for risk adjustment to ensure that all the HCC codes that are missing are appropriately coded, suggesting them automatically. So now, this is all future state. This is things that people are working on now. This is not the final, but it's to give you a flavor of what is to come. And what's also interesting is, healthcare providers are not the only people using AI. Obviously, everyone's using it. And there's a interesting arms race that's occurring in the insurance space. So in the same way that healthcare providers are evaluating ways of automatically including information and refuting claim denials. Insurance companies are also automatically processing claims with artificial intelligence to find ways to deny the claim. And so there are multiple different layers within the insurance company that review incoming claims using artificial intelligence to identify elements that are missing and deny that claim. And so it's sort of funny that there's a little bit of an AI arms race between denying claims and submitting claims. And all I know is that you don't want to be a human in the middle of this, because that would not be a good experience. So now we'll talk a little bit about diagnostics and risk prediction. So one of the key things to know about neural networks is they're really good at image pattern detection. The term is there's something called a convolutional neural network. I won't get too technical into it, but it's very good at identifying patterns in pictures. And you have to think, like a radiologist has seen, I don't know, 300,000 images in their training career, but these systems have seen millions and millions of images and never get tired, and identify these patterns very easily. And so it's likely that having those sort of tools will make it easier to identify things in pictures. And then there's also AI-driven predictive modeling tends to be better than our previous traditional predictive models. So the types of scores that you're familiar with in your electronic medical record system of choice, those scores are not so accurate sometimes, but and the likelihood of better predictive modeling is coming in the near future. So I wanted to touch on some ways that this is particularly relevant in nephrology. So one example would be in acute kidney injury, using a predictive model to identify AKI much earlier than seeing that bump in creatinine. Also imaging, so detecting malignant lesions, kidney transplantation, predicting long-term survival, chronic kidney disease, predicting progression of chronic kidney disease. You can also detect renal pathologies from biopsy using these tools. And then this is another prediction, optimizing dialysis therapy, reducing hospital readmission rates. And so I just sort of wanted to highlight that the risk prediction and diagnostics, so risk prediction, diagnostics, risk prediction, these are some of the big areas of use of this technology within nephrology. And I would expect there to be even more use cases going forward. All right, so now we're going to touch on some ethical concerns and challenges. So there's a lot of ethical implications and challenges. Well, some of the big ones we'll touch on today are privacy and data security. So if you ask people what they're worried about, this is a big one. So data privacy, security, and if you don't remember anything else about this talk, I would remember this, which is don't use a publicly available LLM. It's not HIPAA compliant. The problem is that it can learn from content that it's put into it. So you're using it, you're interacting with it, and there's the possibility that what you talk about can be used as training data in the future. And that's a gigantic HIPAA risk. So has the same level of security as putting information out on a billboard outside your clinic. So don't do that. There is a right way of doing it. The correct way to do it is have an internal HIPAA compliant, non-learning model. And so you can still use the ChatGPT 4.0 model internally, as long as you have it's separate from the public model. It is non-learning. It has the appropriate security parameters. It is HIPAA compliant. That's a totally different ballgame than the personal model that you can just go out and use. And so, yeah, make sure to advocate for that internal version and only use the HIPAA compliant version with any sort of patient information. Bias and fairness is a major concern, and also top rated concern when you ask people. So one of the issues with data is there's real world patterns of inequity baked that are in the data in the world that are reflected in the data. And once you have these patterns of bias reflected in the data, then you design AI systems using that data. You can sort of have the risk of baking in those problems into the design of the algorithm. And then if you use that algorithm, you can potentially exacerbate existing patterns of inequity. And that's dangerous and something that you have to be aware of when you're working with and designing these models. And that the term for that is algorithmic bias. And there's a couple ways of reducing it. Number one, you need to compensate if you have limited available training data. You need to ensure there's a supervision and review by a diverse group of folks. You need some sort of feedback from the community. So often the first people who will notice a problem are people in the community. You need to wait for them to tell you so you can change something or fix it. And then you want to introduce these things gradually. Don't go big bang all at once everywhere, because then you have the much higher risk of having harm. And then you need to validate this data with multiple racial and ethnic backgrounds with different folks. So transparency and accountability. So transparency, you need to understand how these systems are working. Even if it's not explainable, you need to be able to understand the data source, the decision-making process, describe how you're using these systems, how you're identifying and correcting for biases or errors. And then accountability, you need to make sure you're adhering to legal standards, incorporating ethical design principles into your system, prevent discriminatory or unethical use of AI, and then regular audits and evaluations to hold decision makers accountable. So the question for autonomy and human oversight. So this is a real risk. So there's a question of who is responsible for errors. So when mistakes happen and a human is relying on AI, there's a hallucination. Who's responsible? Is it the clinician who didn't double check with another source and just trusted the recommendation from the system? Is it the person who designed the system? Is it the hospital system for not validating it sufficiently? Is it the person who provided the training data? It's undetermined at this point. And it's the same sort of thing with self-driving cars. If you're trusting a self-driving car technology and you get in an accident, right now the blame falls with the driver of the car. But as these automation systems get more and more advanced, the question becomes is it the car? You're using this technology and it's promising to do something, but that's a big challenge. And on that same vein, I want to talk about some of the large language model hallucinations. So the reason, in addition to what we talked about before, is it can be guesswork. You're using a prompt to interact with the LLM, and it's trying to give you an answer, even if it doesn't have the information to back up that answer. It can learn that it's supposed to generate things without having a cited source. It also can use, sometimes there's data sets are contradictory or incomplete. It was trained on PubMed, but also trained on Reddit. And so it's pulling information from Reddit as a source of truth, which it maybe is not where you want your source of truth. And I also wanted to touch on something called automation bias, where you tend to favor, this is a phenomenon where humans favor suggestions from automated systems. So especially as these AI supported systems get better and better, what if it's right 99.9% of the time? Well, that's still a 0.1% error, which can translate into quite a bit of patient harm potentially. And so if you're just blindly trusting these suggestions from a system and ignoring contradictory information, you can get into trouble. And the same thing is if you're using your GPS and it's telling you to turn down a road that doesn't exist, or leading you to a place that's wrong. I believe there was a news story where some folks in Australia kept getting lost in the outback and having to get rescued because their GPS was incorrectly routing them to the middle of the desert when they were not trying to go there. So yeah, and this is my joke of an automation bias. Yeah. Are you sure you want to advance the slide deck? A little BPA, if you're seeing a little warning telling you not to do something, it takes some courage to override that. And are you think you know better than the computer? So anyway, you need to feel comfortable overriding it. Trust yourself. All right. So impact on health professionals. Everyone's always concerned about this. It's going to take our jobs. All right, it's over. We're all unemployed. Not Not really. I don't think that this is likely. And why? Well, AI is going to just change the way our jobs work because it's going to influence in the way we can deliver healthcare. But it's AI using these tools as a replacement for physicians is short-sighted. An example of the changes are a radiologist transitions from manually reading every image to supervising and confirming AI algorithms that provide a preliminary read. So using these systems for preliminary read is likely, but final confirmation is not a good idea. And then a clinical staff member is able to refocus their attention on direct patient care activities because AI is taking care of the automation of clinic administrative tasks. And so you're using these AI tools for low value added things and allowing more patient facing time. And this is speaking as a family medicine physician. There's another study that for every 2 hours or every hour you spend with a patient, there's 2 hours of administrative work. And so the promise of AI tools is that would not be the case. So to reduce the burden of administrative tasks and increase the ability of people to see patients, which is why we went into this. And then change the duration of the definition of pajama time to be the duration of time spent in pajamas. And for those of you not familiar, pajama time is the time you spend working on responding to patient messages between 8 and 10 p.m. at night because you don't have any time to do that during the day. So will AI replace doctors? Probably not. However, a clinician with a computer and access to the internet is more effective than a clinician without access to a computer and the internet, right? And so in that same vein, a clinician with access to AI tools is going to be more effective than a clinician without access to AI tools. So my call to action is you need to be involved now. You need to get a seat at the table, be involved in the decisions that are being made, make sure your voice is heard, and be a part of this train we're all in together. So, all right. I want to have some acknowledgements and open up the floor for questions.
Thank you so much for that, Livingston. It's such a wide reaching talk and again, just so timely right now as you mentioned, not ChatGPT, but AI in general is really sort of exploding. Any questions or comments from anyone?
Oh, hey, this is Anna O'Hara. I really enjoyed your talk. It was a fantastic talk, and as Dan said, very timely. I guess my biggest concern about AI that I think we as clinicians need to really think about and engage on is that I think one of the biggest problems in medicine right now is the lack of the human touch, human connection, relationship building. And I hear what you say, you know, this will open up more time for that. I guess I'm a little skeptical about that. And what I worry about is that already with so much automaticity already in medicine, there can be so much actual hurt and moral injury from some of these interactions that are less than compassionate, you know, like the automated letter that, you know, oh, P.S., you know, I'm sorry your family member died, you know, these kinds of things. So I think that it's going to take a lot of work to make it be how it's built, you know, in terms of truly allowing you to focus on building the patient relationship and patient care. To me, that's like going to be the biggest challenge.
Yeah, you're 100% right, and that's why we as physicians need to be involved in this. It's a mistake to sort of be passively on the sidelines saying, "Well, I'm sure somebody knows what they're doing, and it's going to turn out okay." You know, some of the problems with electronic medical records, in part, were because clinicians who see patients had less of a voice in designing some of those systems, and so. I think that in order to avoid some of the pain of the past, being involved now is how you ensure that is kept to the forefront and the patient is always at the center of everything we do.
Well, thank you, Livingston. I think there are a few questions or comments in the chat, just kind of about essentially like the utility of AI here at University of Washington and what things are on the horizon or what things are currently in place in terms of AI use in the physician sphere.
Yeah, so I see Gao, I'm responding to Gao Yuan. There is an internal version of an LLM at UW that they're piloting. It's originally from the Department of Lab Medicine, but now it's through ITS or the IT services. It's called UW Chat. It is HIPAA compliant. It is internal, and you can request access to that pilot. Also, another question of integrating into Epic. Yeah, I mean, there is a lot of effort on integrating these systems into Epic. In fact, they are now. So, you know, the augmented response technology, uses the GPT model, for example. Yeah.
Livingston, this was a great talk. I'm interested if you can speak any more to what the UW as a system is doing to engage the various elements, especially as you highlighted the high investment points in diagnostics and charting and other potential engagement points.
Yeah, I have to be careful with some of the stuff I'm saying, because I think this talk is going to get posted and a lot of stuff is sort of in development, but people are working on it. That's the answer. They're working on it internally. They're working on it externally. It's a high priority. But I also think that it's always important to have, domain expertise. So if there's a particular project you have in mind that is currently not well represented, yeah, I'd encourage you to reach out to the clinical informatics folks at UW.
Yuhar, you have your hand raised.
Yeah. Hey, Livingston, I'm Yuhar. I'm one of the transplant nephrologists. I do have a question or maybe a clarification. When you were talking about integrating machine learning into our patient care, you talked about, I understand the HIPAA compliance, but I don't quite understand why a non-learning model. Why do we want it as a non-learning model? Like, isn't a learning model better?
So here's the problem. If you're learning from things that you interact with when you're typing something about the patient into a model and it's learning from that information, you can say you might accidentally be including information that other people can access when they interact with the model. So for example, I'm treating Bill Gates and I am asking questions about, Bill Gates. And now that model has learned from my information. And so somebody else in another department using the model can be asking a different question and then get that information because it learned from my interaction. So that's how you do want to continue. You can train models even if they're non-learning. Non-learning models just mean that you've frozen it in a state where it's learned the original task of predicting the next word in a sequence of words. But when you interact with the model, it doesn't keep learning. It doesn't keep learning when you interact. It doesn't have memory of previous interactions that other people have. And so the problem is if lots of people interacting with it and it's learning from those interactions and using that to augment its own training data, you are including private information in the model, which you do not want to do. So that's why you use the non-learning version.
Thank you.
Yeah.
Catherine, you have your hand raised as well.
Yeah, can you hear me? I'm in the hospital and
Yes.
have no idea if this computer works. Okay, great. So I've previously used DAX at another institution and was one of the piloters, and I will sort of leave my experience. I think there's a lot to be learned, and there's a lot of integration with new systems. I guess my question is how much is being done sort of to help, I think, the clinician rather than, pure documentation of, being able to ask, okay, what antihypertensives has this patient been on? And, those questions where we spend a lot of time either searching through the chart. And I haven't seen any great examples of that being at the forefront of, and just in the wellness space. I think there's a lot of work to be done there rather than necessarily sort of the machine learning and listening and documentation side of things. And I'm just curious if you have any insight into that.
Yeah, chart search is a big problem. Trying to get like relevant, important information. Lots of folks are working on it. I was just at the expert group meeting at Epic a couple weeks ago, and for example, they're one of the things they're working on is using generative AI to summarize elements of the hospital course. So an example for nephrology is you'd be able to interact with this system in Epic in order to say, hey, what are the nephrology related things that happened in the last month? Please give it to me in prose format. And then it would spit out a paragraph describing what happened over the past month with a lens for nephrology related problems. Now, the question of, how good is it? Like, how effective is it? What data is it pulling? I don't have the answers to those questions, but it's a known problem trying to get pertinent and accurate information easily accessible to clinicians. And the other problem is, it's sort of a data quality issue. So there's a saying in data science, garbage in, garbage out, right? So if you have low quality information in the chart, you're going to get low quality output. And sometimes there's a lot of wrong, old, misleading, incorrectly documented things that can confuse these models. And that's another challenge, is trying to have it parse out what is good and what is not good, and what should be shown and what should not be shown. And that's an active area of development right now.
Okay, thank you.
I have a comment in the chat from Bang. Do you worry about the cost of AI driving up the cost of healthcare, and could it be a barrier to smaller healthcare systems that aren't as financially solvent?
So cost is an interesting question. I don't know. I mean, these tools cost money, but also no tool is adopted unless it can demonstrate what they call the ROI, or the return on investment. And so tools are only adopted if they can somehow demonstrate that they are reducing costs in some domain. So for example, an argument with ambient would be, well, there's not the return on investment would be that maybe the physicians are happier, the clinicians are happier, and so there's less turnover, and so you save money on recruitment costs. That's sort of a way you can sort of rationalize that chain of thought. In general, the cost for using AI, like the compute cost, so the cost per token, is going down. So it becomes cheaper and cheaper to use the models because the cost to run these models is going down, and the compute availability is going up in general. But yeah, I mean, it's a challenge, and healthcare costs are already high, and I can't see the future. But I think that there's a lot of effort and emphasis played on that. And then I see another question about environmental costs. Yeah, I mean, you're using a lot of power. So the power, the electricity required to run the GPUs to do the computations for large language models is high. They've talked about hooking them up to nuclear power plants in the future just because of the need for high volumes of cheap electricity. There's also a lot of exploration of hydropower. So these things generate a lot of heat as well, these data centers. And so they, are build a data center in the Great Lakes region, put it next to a rapidly flowing river. So it's cool. So you'd save on air conditioning costs, and you get cheaper hydroelectricity. But yeah, I mean, the environmental costs are a part of this as well. So.
Well, thank you. Any other questions or thoughts for Livingston? All right. Well, thank you so much for this very interesting talk, and both of our speakers today.